So I do not speak Spanish. I hope that's okay. Don't know any Spanish, so I'm not sure what he just said. But I would like to talk to you about software architecture security. So I assume everybody here in the room is either an architect or interested in architecture. And you can probably walk circles around me when it comes to how to architect a scalable system. I tend to look at architecture from a security perspective. So I think about, you think about ways that you can implement a system that meets requirements. I look for ways that it can be subverted so that people might be able to breach data and make your application do strange things, maybe deny service, take your service down so that nobody else can use it, and that sort of thing. So I'm essentially a paid hacker. Sort of fun job. Okay, I'm the product security. Actually, hold on. I have an introduction slide. Quick agenda, and I'll try to make this just brief. I'll do a quick introduction, and I'll talk about implementation bugs versus architecture flaws. And then spend probably a bulk of the time on how to evaluate architecture security. And after that, I'll wrap up with some common architecture flaws that I've seen in my experience. Okay, so introduction. I'm Bryan Owen. I'm the product security manager at Medallia. So that means that in terms of software that we develop and the architecture that we put together so that we can get components to sort of orchestrate activities and interact to provide functionality as a system. Those sorts of things are interesting to me, and they're under my purview. I help make sure that Medallia knows what secure coding and secure design guidelines look like, and how we can develop software that's secure. Oops. I have about 10 years of software development. I used to be a Cold Fusion web developer. Anybody here heard of Cold Fusion? It's old. People make fun of it now. But I used to love it. So after 10 years of software development, I sort of made a transition into software security. I've been doing that for about 9 years now. I worked for a company called Cigital as a software security consultant. Eventually became a technical manager. And got a broad exposure to a lot of different companies, a lot of different architectures, a lot of different tool chains, frameworks, you name it. So I got a lot of broad experience. So I did that for almost 7 years. Then I went to work for Amazon Lab 126. That's the group that does hardware, like the e-ink reader, the Kindle Fire tablets, Fire TV, the Fire phone. They actually had a Fire phone. it flopped pretty quickly, unfortunately. Amazon Echo is one of the new pieces of hardware. So that's the little can that you can talk to that answers your questions. As you can imagine, there are lots of neat security concerns around products like that. So I did that for about 1.5 years, and now I'm here at Medallia as the product security manager. So I'm sort of building a security program from the ground up. The kinds of things that I do secure code review, look at source code and try to find patterns, ways that software can be developed in a way that can expose holes that an attacker can come in and take advantage of. I do pen testing, so actually break out some tools and try to get in, see what I can retrieve, what I can see. I also do tool automation. You can't do that day in, day out across an entire portfolio of applications. At a certain point, you want to put tools in place that can do this automatically. And then I help with issue remediation, training. That's really why I'm out here this week, is doing training here at Medallia. Just happened to be here the week that you're here. And developing security policies and standards, doing vulnerability management. I know this list is getting boring, but more to the point, I also do architecture security review. And I'll talk a good bit about what that actually means. Okay, quick introduction to Medallia. This is my sales pitch slide. So Medallia's vision is creating a world where customers are loved by customers and employees. I don't know what the climate looks like here in Argentina, but in the US we have a lot of companies that people really hate. You call for customer service and you get the runaround, and it's not my problem talking to these people. All kinds of crazy stuff. Medallia looks to help those companies. So, where a company has sort of you talk to the right hand and then you talk to the left hand, and Medallia tries to draw those closer together and figure out how can we make companies responsive to their customers. And I'm not so angry. We do that through what we call operational customer experience management. So customer experience management is essentially figuring out how do people view your company. If they have an interaction, they open a bank account with you or they come shop in your store, how do they see that experience? What makes that operational? We collect a lot of customer sentiment data through these surveys, and we turn it into continuous, engaging, and actionable output. So figuring out what to ask people in the first place is an important piece. You only want to ask questions about things that we can actually make a difference with. So just figuring out what to ask customers and when is a big important piece of that. Once we have the information, typically you would gather that information and kind of decide how to make strategic decisions. What kinds of things should we do that would help make our company a little more aligned to customers? We go a little bit further and we help channel that data to the people who can make a difference immediately. So if you're talking to somebody at customer support and have a really bad experience, a manager might find out really quick that happened and have a chance to call and fix that problem right away instead of losing that customer. We have mobile apps that people carry around and check very often. They figure out, how's my store doing? Ooh, I need to contact that person and make sure things are okay. So that's sort of in a nutshell what Medallia does. That's my sales pitch slide. Okay, implementation bugs versus architecture flaws. Anybody would care to take a crack at what the difference is between an implementation bug and an architecture flaw? Don't be shy.
I guess a bug is when software is implemented incorrectly, like it doesn't match the spec or it doesn't do what the programmer hopes it would do, and then that causes unexpected behavior.
Sure.
And an architecture flaw is when the design is just incorrect and that causes behavior no one thought would even happen.
Right, and you said two important things. One of them is the developer makes an error in the implementation flaw, and sort of the design, I guess, is more at fault in the case of an architecture flaw. And I'll talk about those a little bit more. Implementation bugs are usually a local concern, something that probably touches a single component, and probably has little or no impact to the design overall. A developer can probably catch that this is a problem, make a fix locally, and it won't have any ripple effect to the system as a whole. They're usually discovered and fixed in source code, and they're very easily discovered by automated tools, which is very good news. Some examples are forgetting to explicitly dispose of expensive resources after use. So in Java, you open up a database connection, for example, or an internet socket. You use that and it ties up finite resource. And when you're done, if you forget to explicitly dispose of it, it gets tagged as eligible for garbage collection, which may happen in 20 seconds or it may happen never. You're at the mercy of the garbage collector scheduler in that case. So, from a security perspective, in terms of avoiding denial of service to your application, you want to make sure that you spin that up as late as possible and release it as early as possible. That's an implementation bug. You won't see an architect speccing out things like that. Using a non-cryptographic number generator to generate, say, session ID, something that has a security side effect. Using string concatenation to generate queries or commands that are going to be executed. Putting a SQL query together by saying select star from this database or this table where username equals, and then you paste in the username the user provided. What if the user provides a single tick and then says semicolon drop database? That's known as a SQL injection vulnerability, and there are several different things like that. And these are usually detected in source code and fixed in source code. You can see why my job's fun. Architecture flaws, on the other hand, typically span software components, not as a rule, but usually you sort of back up and take a 30,000 foot or 10,000 meter view of the application and see how components are interacting with each other. That's usually where architecture flaws manifest. And they're discovered and fixed in design. if a developer happens to run across an issue like this, the developer doesn't just fix it and we move on. Usually we have to like call a meeting, take a step back, modify our architecture a little bit so that we do this right going forward. So those concerns typically need to be fixed at a slightly higher level than the implementation bug. Is there a question? I saw some. Okay. By the way, feel free to raise your hand at any time if you have a question. I certainly don't mind. Often, an architecture flaw can be manifested from something that's missing. So you don't have a rate limiting control. Say you are not performing authentication early enough in a call chain to avoid unauthenticated users making it all the way back to a component, for example. Those things are hard for, say, a source code scanner to find because a tool doesn't know what your requirements are. It doesn't really know that pieces are missing or that they don't exist somewhere else. These are very hard for a tool to find. Come on. Okay, very hard for a tool to find, and these tend to require sort of more abstract thoughts by, say, an architect, folks like you here in this room. Does this all make sense? Okay. Some examples of that might be weak secret management or no secrets management. You have people just sort of creating a file and shoving keys or username passwords in them. Maybe we need to take a step back and think about how we're going to provision those keys at runtime so that we don't have these files with sensitive information lying around. Weak session management. Session management can sometimes be a very complex process, and we can kind of miss pieces in doing it correctly. Unreasonable transitive trust. If there's a store that protects data and we have a component that provides data, say to a web browser without authentication, that component might authenticate very strongly to the data store to retrieve the data and then liberate that data by sending it without authentication, for example. That's an architectural concern, maybe not something a developer is likely to notice. Authentication and authorization not implemented consistently across entry points. I see that for an interactive web login. Users will get sent into a handler that will do, say, rate limiting and account locking if you put an incorrect password too many times. And then later we decide, hey, we want to allow mobile applications to access this system. And they'll spin up a new entry point for the mobile app and sort of forget to do rate limiting or account lockouts. Because sometimes and I'll talk about this, I have a slide for it, we incorrectly place trust in the client, figuring that, I created this mobile application that's going to be running on the phone, I control how it acts, and I'm not going to let it, make calls too fast. The error there is that you don't have to have a mobile phone to connect to a REST API. I could write a curl script to do that, and make 10,000 connection attempts per second until I brute force a password. No strategy for denial of service protection. That's more an architecture concern than a development concern. Certainly a developer might implement this kind of thing, but really it's one of those things you want to step back and think about as a whole. Okay, in the end, this is a sort of a famous building in Massachusetts Institute of Technology in the United States. It's marvelous to look at. I just thought it was a funny picture, so I put it up there. So the difference isn't really important, especially to an attacker. If an attacker is at home trying to figure out how to penetrate a system, if they happen to find a way in through an architecture flaw or a vulnerability that exists because of an architecture flaw instead of an implementation bug, we don't get to say, hey, that was no fair, that was an implementation bug. An attacker doesn't care. So really the difference between those two is not important. What is important is understanding that not all issues manifest at the implementation level. So if you're doing pen testing, and you're doing static code analysis, let me jump forward here. So industry observations suggest there's about a 50-50 split. We find about half of the vulnerabilities in systems by doing code analysis and penetration testing. We find about half of them by admiring the architecture and looking for weaknesses. So if you're doing the pen testing and the code reviews, those are fairly common. Great, you covered about 50% of the attack surface of your application. Are you comfortable with that? And we have another 50% kind of ripe for the picking. So that's the only point I'm trying to make. That it's important to understand there's more to do than just pen testing your application. Okay, so knowing that, hopefully I've sold you now on the importance of doing security review at the architecture level. How do we go about that? Now, certainly the things I show you here are somewhat entry level. This is a great way just to get started. I mean, these are the things that you can leave and go do tomorrow if you have a whiteboard and smart people who can explain how a system works. So there are a couple of ways to get started. First, you want architects. We love drawings of how things work, right? And I'm one of those people where if I'm talking to somebody about something, I just sort of, my eyes glaze over. I need to see it on a whiteboard. So I can tell visually at a glance what things look like, what's going on where. There are a couple of common ways to do that. Microsoft has put a lot of work into software security, sort of across the board, including doing architecture analysis, threat modeling. They have their own technique that revolves around what is called a data flow diagram. If you ever seen a Microsoft threat model, it looks like this one on top. It has circles to represent processes. It has double concentric circles to represent complex sort of abstractions that may contain multiple processes. These lines, curved lines, show where data traverses between components. These right here are data stores, and then the squares are actors, which can be components or users who interact with the system. There's another technique. I don't know if there's really a name for it, but as I mentioned, I worked for Cigital for a number of years, and this is how we tended to do it at Cigital. In that context, we use control flow diagrams. To me, they seem to be a little bit simpler. I think it gets a little messy when you have these, back and forth arcs between all the components and all that stuff. These to me are neater. I think you can fit more concisely in a page. That's just my opinion. And I'm not suggesting that anybody do it one way versus the other. I'm just showing you what I'm comfortable with. So, getting a representation, a visual representation of the system is an important first step. So, how do you go about doing that? First, identify components. What are the different components in the system? Here we have a data warehouse, reporting server, databases. Here we have a web server that has subcomponents within it. There's really no rule as to how you model the different components in your system. Just make sure that it's software centric and not necessarily deployment centric. A lot of times I'll ask a development team for existing documentation, and they'll send me, like the big stacked, it shows, here's this layer, here's the OS layer, here's the, Android layer, and they got all these boxes, and none of them really show what the relationships are between them. So that's not really what I'm looking for. Maybe even more commonly, they'll have a deployment diagram and show that I have a cluster of 7 servers here, and I have a Cisco PIX, and I have a firewall. And that's all great and important, but again, not really what I'm looking for. I'm looking for active components that communicate with each other and need to, in some cases, authenticate to each other. Need to make sure that they're providing confidentiality so that I can't read information that's traversing the wire. I need to make sure that there's a control at one end that prevents, for example, denial of service by doing rate limiting, that sort of thing. So really these are logical abstractions that should represent software, maybe even functions within software. Here I've got a login block. And if it's relevant to the diagram, I may want to break that down even further to show that there is a component that interacts with the database to, it does hashing of the password and then does a comparison. And then a second block might do rate limiting, a third one might do account blocking. The granularity is one of those, you just sort of play it by ear through experience, so you figure it out. If you get toward the end of a diagram and you figure out that, there's something I had in mind that I think might be a problem, but I didn't represent it in this diagram, you might go back and adjust the diagram to put more or less detail. You might find components that you drew in here that just have nothing to do with anything. You can remove that for clarity. So, like a lot of things, it's more of an art than a science. Okay, probably need to be more than one page. If if you can't fit everything you think is important in one page, there's probably an opportunity for you to break that up into multiple pages for different sort of subsystems. Okay. Once you plotted all the components, now plot what their interactions are with each other. Which components talk to which. And this gets quite important as you start looking at flows and thinking about things that might happen at different points in an interaction. Again, I use control flow. You could use data flow. Data flow, you almost always end up with these arrows that have arrows on both ends. And also indicate on these channels what protocol you use. And sometimes it might be more than one level. I do REST over HTTP, or you might have more layers than that, for example. As you start adding these pieces of the diagram, certain things will start just popping in your mind. Ooh, I want to look at that. For example, I do HTTPS between my client administrator browser and my client user browser when they go to log in, and when they go to the admin and reporting page respectively, they do this over HTTPS. When the client activity feed server, this is a fictitious system I put together that sort of resembles what Medallia does in concept, but this is not Medallia's architecture, I promise. Don't go home and start trying to hack us based on this. But here, client activity feed server sends batch uploads nightly, and it does it over, what, HTTP? At that point, you might start scratching your head and wondering, why do we do HTTP? Okay, a next step is to denote the boundaries. Boundaries don't necessarily need to be network boundaries. There certainly is a very, if not a network boundary, at least a strong logical boundary between your web server and the clients that access it. One rule of thumb is that a boundary will denote an interaction where some form of authentication or authorization or input validation, something like that, either is happening or should be happening. Certainly, if a client is contacting the web server, we should be doing some authentication and probably some input validation. So, that's sort of a boundary you see on almost any diagram that has people on the internet accessing it. I put another one over here for the corporate network boundary. It's usually kind of nice to think about, if I'm a developer here at Medallia, do I have any reason to be able to connect directly to the production database, for example? All right. Then plot your data assets. This, to me, is all the rest of it is sort of building a skeleton to hang these on. At the end of the day, security is about protecting your data assets. If you have a recipe database, for example, that you have on the web, how important is it to protect that recipe database at all costs? Maybe not very important. If we start looking at the kinds of data that we handle and their data classifications, everybody here works for a company who has a strong data classification scheme, right? Is everybody? Maybe not. There's an opportunity. So plot these data assets, and I'll just read. I know this is probably very small for you back there. It's not necessarily important what's here, but and I put a little A04 for asset number 4, and then over here I have a legend that tells me what that actually means, so I don't clutter my diagram with all the wording. So A4 is customer names, which is I'm not sure how the privacy laws work here in Argentina. In the U.S., we call that PII, which is personally identifiable information. You probably have something similar, similar name here. So usernames, that would be an issue. Customer email addresses, again, that's private information. Customer interaction details. So again, we survey people who had some interaction with the company. If somebody, the hospitality industry is one of our client verticals. So if somebody goes and stays at a hotel, that hotel will send an email and say, hey, how did you like your stay at our hotel on May 22nd? It may not be private information that individual stayed at a hotel on May 22nd. In any case, it's not Medallia's place to let the world know that. So we treat that as pretty confidential information. And then we have things like credentials and client API keys and so forth. In this case, I've color-coded them to show their relative data sensitivity. And that also kind of helps you at a glance figure out where your hotspots are, things that you really need to protect. Okay, and just this understanding what those different pieces of data are it's a great exercise to go through with your development teams, unless you're the person that has to know that. Then maybe you don't have to talk to the development team. I don't know. But when I go through this exercise with teams, we usually start out with just a few, and like, is that everything? I'll start asking questions like, do we send a session ID after the user logs in? Do we, how do we do authorization? We've got an authorization table somewhere, right? Oh yeah, we have one of those. Okay, so if somebody tampered with that, they could probably give themselves privileges they shouldn't have. So that's an important piece of data. As you have the conversation, start kind of brainstorming, digging in, you can really flesh this out. And I find a lot of times, even here at Medallia, going through and doing this exercise with different teams, after we were done and we had this diagram, this is the team who explained to me how it worked. Afterward, they say, wow, that's an awesome diagram. Can we have it? So just doing this exercise provides value to the development teams. And lastly, this is sort of an optional step, but I like to do it because it helps me brainstorm when I start thinking about ways people can attack systems. Start plotting who the actors are that interact with your application. You'll pretty much always have, an authorized user, the person who is intended to use your application as an end user. And then you've also got the guy or the girl who likes to sit next to that person with their laptop at Starbucks on the unsecured Wi-Fi network, sitting next to them, see what they're up to. So an external attacker, this is somebody who has no business or has no credentials to use the system. That would be certainly another threat actor. And down here, I've also plotted the internal administrator. In a lot of cases, people will say, we have to trust our administrator. We have to draw the line at some point. We pay this person, we trust this person on our payroll. What are we going to do to prevent our admin from doing their job? And in a lot of cases, that's a very good point. So, we'll acknowledge that the admin exists, and maybe we can just want to understand what the risk is. An admin could go and exfiltrate a whole bunch of data and go sell it to somebody if they wanted to. This happens a lot. I think Google just had a breach that was because of an insider who had access to data that they were able to exfiltrate. I'm not sure what they did. I don't know the details of the story. AOL also had a humongous breach by an insider. Same thing. They had a person who had way too much access to data internally. So you may want to think about, if this person connects to a database and does a query, should they be able to retrieve 2 gigs worth of data? Is that normal for a call center employee? Is that normal for So think about it. And then the corporate user, this is the developer sitting at their desk. Should that person be able to connect to a database and see things?
Wasn't that the case with Snowden?
Snowden was an administrator on the inside, and where he was working, I think they probably should have been looking at very strongly at what can our internal people get to. And you see, like in financial situations and even government, especially intelligence context, that we start thinking about, should an administrator be able to get at anything they want? Should they be able to pull down tons of data? We really need to compartmentalize. And sometimes you can even go to the extent of doing like division of responsibility and say, here's a staff of administrators, we have 5 of them, and if that person ever wants to extract data from our data warehouse, we have to have at least 2 of those people present. And they'll have fragments of keys. You have to have at least 2 of those together to get some. Then you don't have a lone actor doing this kind of thing, and you're much less likely to have an Edward Snowden type of incident. Okay. Then also some other things to consider: plotting existing security controls. At Sigil, they do this. They generate your diagram, and then they give you credit with a little green block to show wherever you have a control in place. Here there's HTTPS, so they'll put a green block and then say, for that green block they're doing HTTPS. And then you can sort of see, where all the green blocks are plotted. If you have a green block missing, you probably have something to look at. If you have a green block, you still want to make sure that it's a sufficient control. So I'm sort of split on whether I do that or not. And use cases, as an architect, you may not understand how people actually use the system. What's the normal flow that they use to go through the application? Is there a self-registration feature? What kind of profile information do people update? It's nice just to know what the use cases are, how people interact with the system. Again, helps you get thinking about ways that people might attack. Misuse and abuse cases. So we know in the happy case how people will use the system. Start thinking about ways that people might misuse the system or outright abuse the system and try to break it. And also, if there are process or protocol flows, you make you pass a certain piece of data, something else happens, and after that, you provide some other piece of data, and then it gets encrypted. Sometimes it's important to see the temporal layout and know what happens when, what pieces get added when, especially if you're looking at things like the TLS handshake. Trying to figure out how is that secure, how do we securely transmit a key to establish a session key, at what point do we know that this is secure. SAML also has its own flow, so user gets redirected in the browser profile anyway. User gets redirected here. They provide credentials. They get a bearer token maybe that they provide somewhere else. And a public key has to be exchanged beforehand, and if you're not doing that, then you might have a problem. OAuth is another one. Okay. Once you've done that, you want to admire the architecture, the security architecture that you've written, and try to figure out how might people attack that system. If you're just staring at a diagram and trying to figure out how people might attack the system, that can be sort of difficult. So Microsoft, I give Microsoft credit for this. They invented a mnemonic called STRIDE. And STRIDE is just a series of different ways that people might try to attack a system or things they might try to do. And they really help get the creative juices flowing when you're trying to brainstorm how people might attack your system. So we're looking at things like spoofing. That's trying to pretend that you're somebody that you're not, whether it's by providing their credentials or taking advantage of something else that gets the system to think you're somebody that you're not. Tampering. That could be tampering with information in transit. If you're using HTTP, an attacker, an active man-in-the-middle attacker can tamper with stuff. If you have, say, a SQL injection vulnerability, somebody might be able to carry out an update statement that goes and writes information into the database. I saw a worm that acted that way. This worm would go and query against a meta information table to figure out what the schema looks like, and it would enumerate every text field in the database and then start shoving the link to a website that delivered a malicious payload into every single text field in the application. So somebody, a legitimate user comes along and views a page and they query, grab some data, fill out a table or whatever on the screen, and now it contains, where it's supposed to have legitimate information, it's got links to a site that distributes malware. That's also very obviously a tampering attack. Repudiation has, to me, more of a legal connotation. So repudiation is the ability for you to carry out, actually no, I think this is good, carry out an activity and to be able to later say, I didn't do it, and you have no way to prove it. Non-repudiation is sort of the opposite. You having controls in place that ensure that if somebody takes out an activity, you can pin it to that person definitively. We usually use PKI, private keys, signing, things like that, in order to enforce non-repudiation. Information disclosure, that's your classic breach. Somebody's able to go and grab all kinds of passwords or, like LinkedIn. Denial of service, it can take a couple of, at least a couple of different interesting forms. One of them is just, like Anonymous, the group Anonymous. They have tons of people from different places just hammering a website until it gives up. That's one, but another would be locking somebody's account out, for example. I've got a slide where I talk about that, it's fun. Elevation of privilege, so I'm just a regular user, but can I coax a component that operates under high privilege? Can I get it to carry out some activity for me, for example? Okay, so STRIDE is just an aid. Excuse me. Again, it's meant to sort of help you get your creativity rolling. If it works for you, great. If it doesn't work for you, or if you're nailing it, you're finding all kinds of neat things, you can just set STRIDE aside. But if nothing else, it's a great place to start. So here, using STRIDE, we're going to look back at this example architecture, and we're looking just at the HTTP channel between the feed server and the active feed service. Spoofing. This client provides a key to authenticate to the feed service. Is it predictable? Is that something that I can guess? If I write a Perl script that just sits there in a loop, generating new API keys, am I likely to be able to find one that's valid? If the API key is like a 3-digit number, it seems like a high likelihood you can do that very easily. Tampering. What if I impersonate this client activity feed server and I shove in data that describes things that didn't really happen? Repudiation. Can I guarantee that activity feeds that I receive here actually came from the client that I think they did? Can I harvest the API key in transit? That would be information disclosure. Well, it's going over HTTP. So, if I can listen on that network, I can probably harvest that. Denial of service. Is there any rate limiting for the activity feed service? What if somebody enlists a botnet and just starts hammering this REST endpoint? If I exploit an injection vulnerability, can the activity feed service cause damage to its host? So this component, well, you're a completely unprivileged user out here, or your privilege is limited to uploading a table full of data, you certainly should not have the permission to, say, delete files in the file system. What if the activity feed service is operating under a user context that can do that? And what if there's an injection vulnerability that I can exploit and get it to delete it directly on the server? So that's how you use Stride to sort of think about different ways that you can attack a system. And so that list, and that's a pretty decent list, applies to just this single channel. Now repeat for every component. Actually, if you use the Microsoft SDL threat modeling tool, it's free. It used to sit on top of Visio, so it was free, but you had to own Visio, which is not free. But now they have a standalone tool you can use. And what it does is it essentially it gives you an interface to create all this stuff and all the data flows. And then it does essentially a Cartesian join between Stride and every single component in your architecture. And that can get really tedious. So I don't recommend that. Okay, and then turning this into a threat model. Now we have an architecture that we can take a look at. Now we'll do the threat model. I've already sort of foreshadowed some of these pieces. So when doing a threat model, you can tailor this to your needs, but here's what I typically do. I'll describe an attack. So who will use what attack against, oh, that's weird, the font's got all weird, which vector in order to access what data asset. That to me is a threat. And here's an example. An external attacker carries out a man-in-the-middle attack on the HTTP channel between the feed server and the web server in order to steal the API key. That tells me everything. It tells me who, gives me an idea of what privileges you would have to have. If there's more than one threat actor that can carry it out, find the one that has the least permissions, because that's the scariest, right? And that's really going to drive the point home for whoever it is that writes the checks or makes the schedule and tells people what to work on. Hey, an unauthenticated user can exfiltrate. It tells you who, it tells you what they can do, which gives you an idea what the remediation might be. And it tells you, it gives you information that helps you figure out what the risk would be. So now you can take a risk-based approach and figure, if I have a finite amount of resources to throw at problems, which ones do I want to attack first? That's a very important question. As a bonus, you can, if you create a thorough threat model, so in this case, we talked about, imagine we're using HTTPS on that channel. We probably don't have a problem in that case. Do we need to write that down as a threat? Do we need to put that in our threat model? Any opinions? Raise your hand if you think yes. Raise your hand if you think no.
That depends on how do you allow, well, on the criteria to allow or not access to your servers. Is if you allow access through HTTPS only, then it shouldn't be there. But if you do, then I think it should be there.
Sure. I would argue that even if the problem is solved because you're using HTTPS on that channel, still write it down. If somebody else comes to look at it later, at least they know that you've shown your work. Right? So they know that you took a thorough look. They don't say, wow, I wonder if this guy thought about HTTPS. That's one, but perhaps more importantly, you can turn these around and say an external attacker must not be able to carry out a man-in-the-middle attack on the feed server and retrieve the API key. Once you flip that around, you have a security requirement. How many of you work with organizations that actually well, write down requirements in the first place. In the agile world, that's less and less common. Good. Well, I say good. You don't necessarily have to do that. And even in agile world, you sort of capture them in one sense or another. You have stories and epics and things like that, and your little 3x5 cards and whatever. But it does decentralize your documentation a bit, and sometimes you don't really take a thorough, comprehensive look at security requirements. Here's a great way to generate some security requirements. And you can hand them off to your QA team and have them start writing QA tests. Security regression tests. QA tests traditionally test functionality. User must be able to log in. User must be logging out if they or locked out if they try 3 times and fail. But do we sort of flip that around and start looking at attacks against this system? User must not be able to carry out SQL injection. User must not be able to carry out a man in the middle on the communication channel. Very important to have those security requirements. I would, on the level of maturity of an organization, I think threat modeling is probably somewhat advanced, and doing security regression tests probably even more so. These are people who don't have a lot of time, don't have security expertise, so sometimes this is an uphill battle. This is one of my goals for Medallia, I think, probably in the next year, maybe 2. We'll see how that works out. So anyway, complete threat model. I would say even if you think problems are fixed, still show that you thought about them and make security requirements out of them. Okay, last thing. Now we have this list of threats against our system. Then what? Do we start at number 1 and start fixing them? We always have to take a risk-based approach, especially when we start talking to business people who are writing checks and deciding whether it's more important for you to work on a feature or a bug fix, and of the bug fixes, which one should you work on first? Oops. So assign a risk level to each threat. NIST is a U.S. organization. I don't know how popular this is down here, but it doesn't really matter. It's not really tied to this government organization, but they made a proposal in terms of vulnerability management that in order to determine what risk is, look at the impact of a vulnerability and then look at the likelihood of it being carried out. And once you look at those, you can kind of figure out what the risk is. So when you look at impact, what's the impact of the attack, assuming it's carried out? Now in the case of a man-in-the-middle attack on an HTTP channel, we can say, oh, we're using HTTPS, so there's going to be no impact. No, what we're saying is assume that it can be. We'll get to the likelihood later. Assume that it can be carried out. What would be the impact? Well, somebody's able to siphon off the credentials and impersonate your users, maybe exfiltrate, and that's pretty darn important. So I would rate the impact of that as high. Likelihood. What's the barrier to the exploit? In the case of HTTPS, the barrier would be pretty darn high. How do you break a TLS connection? Well, this is not counting the plethora of attacks that have come out in the last 2 years on SSL version 3 and so forth. Let's assume we're doing TLS right. The barrier to exploit would probably be pretty darn high. If you're not using HTTP, the barrier would probably be very low, I think. Although you still have to be able to plug into the network the person is on or be sitting next to them at a Starbucks, for example. So maybe it's not as low as you'd think. Maybe it is sort of a medium-ish likelihood. What we do not want to consider is whether we think somebody, given the technical ability to do it, do we think that they're likely to do it? Do we think their conscience is going to get to them, they're going to decide not to do it? That's not what we're talking about. I think you always have to assume if there's a vulnerability, we have to treat it like there are people who will have a motivation to exploit it. Yes?
I have a question. If you propose to not to ignore but to move to a second place the likelihood, why consider it altogether?
Why consider
it anyway? I mean, you just said that even if it's not really likely to happen, a certain breach, you should take account. You should take it into account always.
Right. Okay. I'll try to make that a little more clear. So the question was, if we're not trying to think of how likely somebody is to carry out an attack if they're able to, then why even consider it? I'm trying to draw the distinction, and maybe I didn't articulate it very well. What we're really, in fact, I think likelihood is a misnomer. I think it should be called barrier to exploit. What is the barrier to exploit? Would you have to be able to crack a TLS key Would that take a whole bunch of Amazon EC2 compute power in order to brute force that? How long would it take? How much money would that take? Are there access requirements? Do you have to be inside the building to be able to plug into a jack? If they have good physical security, then maybe that would be hard as well. That kind of reduces the likelihood. Are there timing requirements? Do I have to be able to send 2 requests within milliseconds of each other? Do I have to know somebody on the inside? Things like that. Those are all things that reduce the likelihood. But trying to get inside the head of the attacker and figure out how likely they are to want to do it, I think, is outside of our realm of expertise. There are professionals, I guess, who think about that sort of thing. I'm not one of them. Okay, so for an example, I sort of flipped here, and I noticed this really late, and I didn't update my deck. I'm not thinking about the same attack where somebody watches you logging in and tries to scrape your credentials. This is somebody trying to impersonate the data feed server. And I think the impact is probably medium, because the attacker can forge custom interactions. It's a write-only interface. They can sort of try to cloud up the activity database, but they can't deface it, they can't delete records. So I would call that medium-ish. And the likelihood, it's sent. The key is sent over HTTP. There could be employees sitting in the building who could plug in and get to it. So I'd consider the likelihood high. You might convince me that it's medium because you'd have to be in the building, or but if this is something that ever runs on a laptop in a Starbucks, then I'd say it's still high. And therefore the risk is high. And finally, to put a bow on it, it's one thing to tell somebody you have a vulnerability and it's a big one. The last piece is, how do you fix it? So in this case, employ TLS. Okay, how am I doing for time, by the way?
We've already got like 15 minutes.
15 minutes? 10 minutes? Okay, I'm going to burn through these then. Common architecture flaws. So what is Homer to do? Homer and Quickie Mart. There's somebody sent some references here. I had to throw a slide in. Authenticating client software. I see this a lot. People really genuinely want to be able to distribute, say, a mobile app, and they want to make sure that when somebody calls the API on the server side, that it is that mobile app that they wrote and not some imposter software or something like that. Using HTTPS for a login and then going over to HTTP. Very common. It used to be very common, sorry. For a lot of people who might surprise you. Weak session management. There are a lot of things that can go wrong with session management, and often do. Misplaced client trust. Trusting the client to take care of, say, validation and that sort of thing, instead of doing it at the server. And incremental expansion leads to control bypass. I couldn't think of a really suitable title for that, but really it has to do with complexity. As systems grow and you start cobbling pieces onto it, you can start forgetting security assumptions that were made during design. And then a fun one, where security control essentially turns into an attack vector. Okay, authenticating client software. So here's a mobile device, could be Android, could be iOS, and we have an application binary we distribute that's through an IPA file or an APK, and baked into that binary is a key of some sort. And that key is what the application uses to call the API. And we figured, hey, we distributed this application to the device, they installed it on the device, verified signature, we had tested for, they installed it, and now it's got our key in. So when they call and they provide that key, we can be comfortable knowing that it was the software that we wrote. How many people in this room would be comfortable with that as a security control? Everybody would be comfortable with that? Okay. Well, the picture hopefully gives it away. Come on in, the key's under the mat. Twitter tried this once upon a time. They had an official Twitter client. And if you use the official Twitter client and it called the Twitter API, they did no rate limiting. You could send tweets as fast as you wanted to. If you're anybody else, you're going to have to go get your own key provisioned, and that key would rate limit your posting. And you could only send, I don't know what the rate was, but it was some reduced number of tweets. And people, you're stifling third-party support for your ecosystem. Why would you do that? Well, it can be trivial to find a key in a binary. If it's a Java application, it's bytecode, and you can JAD that and turn it into source code essentially, and turn it right back into source code. You might have lost some variable names and so forth, unless the developer was kind enough to include symbols in the APK, which has happened. But even if not, you essentially turn in source code and start looking through string literals and say, hey, what is that? That looks like a key to me. Or even aside from that, you can proxy your own information, set up your own proxy, and just watch that call go out and see what key gets passed. And what happened with Twitter was that very quickly somebody figured out what the keys were for the phishing Twitter apps, posted them on the internet. And instead of having a security control, they had no security control effectively. And in fact, it was worse than that. They had egg on their face. Twitter was so arrogant as to try to do this, and they, they wrote this key into the file, and we busted them. And now Twitter looks dumb. So no company wants to look dumb for trying to do something like that, right? If you're putting it on a mobile device, you have to expect that it's exploitable, as a general rule. It's difficult to revoke if somebody starts setting the key who is not the actual client, and you're able to figure that out somehow. How do you shut off just that client? It can be hard. You can try things like blocking an IP, but if you're on a mobile device, your IP changes every time you skip to a new mobile tower, right? And it's impossible to fix without a redeployment. If you want to fix it and try to throw them off the scent by baking in a new key, now you have to redeploy to all these people, and then you're back in the same boat. Somebody's just going to find the key again. So even if it's obfuscated, a rooted phone makes it very hard. You can attach a debugger. You can do all kinds of crazy stuff. So there are frameworks like Arcsan. Anybody heard of Arcsan? If you have a mobile app and you're interested in protecting secrets on the application or trying to attest for the software, if you insist that you have to do that, Arcsan is a good place to look. They have a framework that you can use that does code obfuscation. It does hash checking to make sure that you haven't modified your code. It does anti-debugger. It can tell if you have a debugger attached, and it will refuse to load keys, things like that. All those are sort of bypassable. If you're motivated and you have the time, you can get around those things. You can patch around the call that checks your debugger. But if you start adding these guards and having other guards, watching each other, it gets exceedingly hard. You raise the bar incrementally pretty well. When I worked at Cigital, we did an assessment of Arcsan and found it to be a pretty novel and useful tool. Okay, HTTPS for login and then HTTP. Hotmail, Facebook, Yahoo Mail, I'm not sure who else, maybe even Gmail at one point. All these companies would send you, when you went to log in, they would send you to HTTPS. You put in your credentials, they'd go over the channel encrypted, then you would go back to HTTP. Well, how do we maintain session state in an HTTP world? HTTP is stateless. How do we maintain state? Anybody? With cookies.
Yeah, using cookies.
So, person logs in, you authenticate them, you actually, I always fall into this trap of equating a JSession ID or an ASP.NET session ID with login state. You actually usually get that the first time you hit the web server, whether you're logged in or not. But you have session state, you have this cookie that the browser passes back, and it uses it to look up in the local collection and say, okay, here's your session state. Are you logged in or are you not logged in? And that session ID gets passed with every request the device makes. You pass your credentials over HTTPS, we authenticate you. We flag you as now authenticated, but you're still sending that JSession ID or whatever session identifier in the clear. Is that okay? So that session identifier, there was a tool called Firesheep, and it would let you plot down like in Starbucks. And as people logged into Facebook or whatever, these icons would start popping up, and you could click on it, and you would be logged in as that person. Beautiful. It was beautiful. And really, I think that was a reaction to the hubris of these companies saying, well, we're not worried about it. We send your credentials in the clear. Why do you need? Well, here, I'll tell you why. TLS has a bad rap because it uses asymmetric cryptography. When you establish a TLS connection, use asymmetric cryptography to transfer a session key, a symmetric session key. So you only use it just to get that key securely transferred so that each side has a session key they can use. From there forward, it's all symmetric cryptography, which is incredibly fast compared to asymmetric. So that asymmetric hit is very small up front. And especially now with session resumption, a client can say, hey, here's a session ID from our last session, and you can resume without going through the key exchange. TLS these days, the impact of TLS on performance on that channel, maybe 5%, maybe. So I think TLS has a bad reputation and it's undeserved. And that's why people do that. They go HTTPS, do the slow part for the login, and then they want their performance back. So that's not an excuse. Session credential is still a credential, only in this case, this J session ID, for example, is time bound and it's bound to a server. Also, whereas if you saw a username password, that person might use that username password on LinkedIn, Hotmail, all these different places. So if you know that, you can probably, the blast radius is huge. Whereas with a session ID, you can only use it to get into the server for a certain amount of time. So you've got that, but still it's not good at all, sending session IDs. We're probably doing, I'm probably running short on time. I always do this. Let's get to talking. I'll just burn through these quick. Things you do not want to do in session management. Send the session ID in the URL. Somebody can peek over your shoulder and see it. HTTP daemons will log the entire get string, including your session ID. It'll go into your browser history. It's just not good. Don't do it. And the J2EE spec used to say you can put session ID in the URL to support people that don't support cookies. They didn't take any position as to whether it was a secure practice or not. And a lot of people did it just because you want to change that session ID at login. If somebody runs over to your machine while you're at the restroom and writes down, goes to your bank website and writes down that session ID, runs back to their machine and spoofs that cookie. Now you go to log into the bank, they're suddenly logged in as you. So you should always change that session ID, abandon the session so that a new one gets issued and issued over HTTPS.
Sorry, will that still happen if the user doesn't log in again? So if you go back to your computer and you keep working on a session that's still active, they will still be able to use it. Right? So say you're changing the session ID once you re-log in, but they say that the session is still active.
The old session is still active? If the old session is still active, you're still impersonating, yes, you can still impersonate that session, but that session never logged in. So you're, to the bank, you may as well be just any person off of the street. A new session was established.
No, I'm saying that what happens if you still don't have a new session, so you still, let's say I'm working on my computer, and I go to the restroom, and someone grabs my session token, I go back, I keep working, the session is still active.
Right.
So they could still impersonate, right?
Yes. Yes, absolutely. That's
how do you protect against something like that? Do you just rotate the session every minute?
Shorter sessions.
That's a good point. Okay, I'm sorry, I didn't understand your question as you asked it the first and second time. So even if you change it when the user logs in, now I have a new session ID, and that old one is now worthless. But if I stay logged in and then I go to the restroom again, or I go to talk to somebody in the next row, somebody could come over and inspect that session ID and then impersonate your session. That's part of the threat model. What's the likelihood of that happening? Is that something we're worried about? Very good point. There are frameworks that issue a new session ID on every page hit, probably for that reason. Just so even during the session you're rotating your session ID. I've only seen one framework, I think it's called Pyramid, that actually does that. That's the only place I've ever seen it. That doesn't mean it's not a fantastic idea and everybody shouldn't do it. But,
just don't put the session ID on the URL.
No, but even if it's like cookie, I'll take it. No,
Yeah, but for the cookie, he has to go and see your cookies, and somebody will see him look at
just
your
typing
computer.
alerts document.cookie on the URL.
Yeah.
So that's a neat trick, actually. I'm sorry, I'm probably going to run over on time by a few minutes.
Sorry.
It's okay. In your browser, you go to the address bar, you can type in javascript:alert in parentheses document.cookie in parentheses, and an alert box will pop up and it'll show you the names and values of all the cookies that you have for that website, including the session ID, unless you protect against that. And I have a bullet for that. So that's a great way to find out what somebody's cookie is. You don't want session IDs to be predictable. There was a case where Verizon, I think it was, had a technique where people who got new Verizon phones could go set up their device with the network and they were setting session IDs that were an incremental integer. And so I would get session ID 1124, and I think, what if I try 1125? And sure enough, somebody else is logged in as that person. They should not be affixable. If you're the server and somebody passes you a session ID you've never seen before, once upon a time, HTTP servers will say, I've never seen that session ID before, but I'll go ahead and create one with that session ID and we'll just use that. So now I send somebody a link and say, hey, will you check this out? It's a link to their bank with a session ID in it that I already know. So now I don't even have to walk over and figure out what the cookie value is, but I set it for them. If you use HTTP containers like Jetty and so forth, they do this right now. But it's worth understanding if you ever try to roll your own session management. The session ID cookie should never be sent by HTTP. We talked about that a minute ago. The cookie, if you don't set it to secure tells your browser, you've got this cookie for me, this website. If the user connects over HTTPS, send that cookie value like you normally would. But if they connect over HTTP, do not send it. And that's important. You don't want somebody to get somehow redirected to HTTP and now send it in the clear. HTTP only is sort of a misnomer as well. It sounds like the opposite of secure. What it really means is the browser can send it to the server on every page hit. But it should not be available for inspection by script within the browser. So if I have JavaScript running, I can't inspect cookies.jsessionID. There's rarely a case where you would ever have to do that, if ever a case where you'd have to do that. So that's a great protection right there. And also, if you do that trick where you say JavaScript alert document.cookie in the address bar, you will not see the value of an HTTP only cookie. The domain and path not scoped properly. You can have, has anybody incorporated like Mashery into their architecture for API management? Everybody know what Mashery is? So Mashery is like a reverse proxy. You set up REST services that you want to provide to clients, but you don't want them to connect directly to you. So you use Mashery. It's a hosted service out on the internet, and you can register a host name. Say like at Medallia, we could say, well, we want api.medallia.com to resolve to a Mashery server that we don't actually host. It's somewhere else in a data center. And they receive the request, they parse it, they decide how to direct it on our end. But users don't go directly to us, they always go through Mashery. Well, if we do api.mashery.com, register that host name, but point the IP to Mashery, a user comes to me, they log in, they get a cookie set, and if we set the scope, the domain scope of that cookie to .medallia.com, that means any .medallia.com service the client can send a cookie to, even if they go to api.medallia.com, which is not hosted by us. So now we have our clients sending their session cookie to Mashery, somebody who's not even in our organization. So be very careful about the domain scoping. Path is similar. If somebody's in /app1 and they log in, should that cookie be sent if they go to /app2? If you're in a multi-tenant environment, probably not. When somebody logs out, don't just delete the cookie from the browser and leave the session active on the server, because if anybody was able to record it, even though you think you've logged out and killed that session, it's still active. This is somewhat common as well. Mobile apps maybe more often than web. Session should definitely, those go together, definitely abandon the session on the server at logout, and don't have a timeout that's too long. Usually 30 minutes is a sweet spot. Some people for convenience will make it longer, some are very paranoid will make it shorter. This is just a very quick one. Misplaced lack of trust, fox guarding the hen house. What if you logged into a website and it said, hey, with Authenticating, you said, hey, your role ID is 38, and that might be like a store manager or something. I say, laugh out loud, what about role ID 1? You pass that back. Does the server validate that? Hopefully. You should always implement security controls on the server. Do it on the client as well, just for convenience, to avoid round trip, performance or whatever, but always validate on the server as well. And that can also happen in the case of client-side validation. If you should only have, say, alphabetic characters in a field, if you use JavaScript to make sure that happens, what if the user goes to submit that, but they submit it through a proxy where they can halt that request and then tamper with it before they send it up? What if they disable JavaScript in the browser? So don't trust the browser. Assume that anything coming from the client is absolutely malicious until you have a reason to believe that it's not. Okay? I love this image here. this is the incremental expansion control bypass. So what if you have an interactive web login form, and you have handlers that they handle your login, but they also do rate limiting, they do lockouts before they give you access to a resource. I wish I had made that come up later. Now you have a client, like a mobile client, and you develop a new login endpoint for that use case. I only want mobile clients, and I think that only mobile clients are ever going to call that. They're the only ones that know the URL. This person wants to try to brute force an account, but they don't like this rate limiting lockout. So let me try the API endpoint. Document your security controls and be very wary of. We already have a control here. Why not? Use that. Hopefully, there was a very good reason for not using the same one or whatever. But if you start picking up code and copying it somewhere else, hopefully that's a red flag. You think about that. And here's the fun one, and this is the last one. eBay. All familiar with eBay? They have a feature that a lot of people have. If you try to log in and you fail your login 3 times in a row, your account gets locked out. So that's a good security feature, right? Now, when you go to bid on an item, once upon a time, they don't do this anymore, and there's a very good reason why they don't. Once upon a time, you would have a thing, you're looking at the item and say, highest bidder name, B. Owen. So if I'm a person competing against B. Owen and I really want that item, right before the bid, I'm going to go log in as B. Owen with, we'll lose this auction, or something, and I'll do that 3 times in a row. Now that person gets locked out, and they cannot win against me in the bid. So that's a great security feature that got turned into a denial of service vector. So, just a kind of different way interesting way to look at a security feature. Okay, and then there's a feature called fail to ban, and what it does is it scrapes login logs. As people try to SSH in or whatever, logs get created saying whether they succeeded or failed. Well, fail to ban is a daemon that will run, and it'll sit there and look at that log, and it looks for things like user failed to log in. And there have been 8 CVEs, that's a common vulnerability enumeration. Whenever a well-known exploit and a well-known piece of software gets discovered, they'll put it in this database. 8 of those have been recorded between 2008 and 2014, and a majority of them were vectors where somebody could fail a login in such a way that they forged a log entry or caused something else to happen, where I could force a ban of another person. So I could, spoof an IP address, and it would think that I logged in from a different IP address I did, and now I locked out the guy that's next to me. A lot of fun, right? So that's another case of a security feature turning into a denial of service vector. Okay, I'll leave you with my favorite security quote ever. In non-security testing, so like functional, what you think is traditional QA, we need to verify the system does what it's supposed to. Well, in security testing, we must verify the system does what it's supposed to and nothing more. Kind of interesting way to look at security versus quality. Okay, that's it. All right, it's very warm in here, and I'm standing between you and beer, but if you have any questions.
When you were talking about risk, you have what were the impact,
Impact and likelihood.
But you didn't have the cost to fix, which is actually relevant when you're, is that model somewhere, or you just have to talk to your manager and ask him if you can afford it?
Right. So I guess I'll say in the organizations that I've worked in so far, this is true, I think, of any developer, and as a project manager, you should make sure this kind of thing doesn't happen incorrectly. The engineering organization is going to be fixing it. So unless you're the security guy and you're in the engineering organization, it's probably not fair for you to determine what amount of time that it's going to take to make a fix. And you may not have the contextual knowledge to know. I brought a security fix, I raised a vulnerability ticket within our organization and asked a piece of the organization to do some work. And I could have anticipated this, and I was not so much careless about it as figuring this would work itself out. But I said, we need to do this across the board. And I went and sat with the project manager and a developer, and they said, this is crazy. This is going to cost us so much work because we have legitimate cases where people are doing this. We just can't block it across the board. And so it would have been entirely unfair for me to say, this is what it's going to cost for you to fix it. Because there's, changing that line or two of code, but then there's also sometimes going to make sure that users aren't going to be impacted, or if they're going to be impacted, use a phased approach, right? All that, that's a big can of worms and is not always immediately evident. That said, especially when it comes to implementation bugs that may not have that ripple effect, sometimes you can take a stab at what the effort is going to be. But really, from my perspective, I always leave that to the engineering team to tell me how long it's going to take. Hopefully that answers the question. All right. Any other questions? Everybody wants beer? All right, thank you so much.
Thank you.